Bismillahirrahmanirrahim. Now we'll go to this problem. We'll continue doing these problems. Okay, the base is semicircle of radius 1. I have a semicircle, radius 1. This is -1, this is 1. Okay, but our cross-section perpendicular to the base are squares with their two vertices in the semicircle. Two of their vertices in the semicircle. Okay, so this is x, because this is the point x and y. I have the formula x squared plus y squared is equal to 1. Okay. Now, parallel cross sections perpendicular to the base are squares with two of their vertices in the semicircle. So you have x and x. So it means the cross section is perpendicular to the y-axis. So this is the base. Okay. So I have the area of the square, or the size of the square. The square will be like this. I have 2x, 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 2x. So the size of the square will be 2x. And the area of the square will be 2x squared, which is 4x squared. Okay. And the area is what? Now I want this perpendicular to the y-axis. I want to have everything in terms of y. So I have this is 4, 1 minus y squared from here. So now we have the volume. The volume will be what? The volume now in terms of y. So this is 0. This is 1 in terms of y. So it's from 0 to 1. Yeah, squares. So just the square of this. This is the square. This is the area of the square. This is the area of the square. 1 minus y squared dy. Now do the calculation. That will be 4y minus 4y cubed over 3 from 0 to 1. And that will be 4 minus 4 over 3, which is 12 minus 4, 8 over 3. And that will be the answer. Okay, the volume of the solid obtained by rotating the region enclosed by the curves, this, y equals x squared and y equals sine by x over 2 around the x-axis. Okay, I grab the function. I have y equals x squared. Sine is something like this. We'll do something like this, then come back. Okay. And they have it. Yeah, I need this point. When we have inequality. Yeah. Very clear. If x equal 1, then I have sine x by over 2, which is 1, and x squared at x equal 1 is 1. So this is 1. It is very clear this is 1 by inspection. Okay. Now I want to find the volume. Okay. And this is my perpendicular to what? This is the region around the x-axis. So this is perpendicular to the x-axis. So I have capital R of x is the sine. Is the what? Is the sine by x over 2. Sine by x over 2. That will be capital R of x, which is the sine. Small r of x is be what? It will be x to the power 4. X squared, which is, yeah, x squared. So the area will be by, yeah, this is y equal x squared. So the sine is above the, okay. The area will be by sine squared by x over 2 minus x to the power 4. Okay. And that give me what? So the volume will be by, from where to where? From 0 to 1. That will be from 0 to 1. This function minus this function, sine square by x over 2 minus x to the power 4 dx. Okay. Now we need to be careful with this one, using this formula. So that means sine square by x over 2. So my theta is by x over 2. That will be 1 over 2 minus cosine minus half cosine to this minus half cosine by x. So this is will be by from 0 to 1 half minus half cosine by x minus x to the power 4 dx. So that give me what? By half x minus 1 over 2 by sine by x. Okay. Plus minus x to the power 5 over 5. That from 0 to 1. From 0 to 1. That will be by half minus. Sine by is 0, gone, minus 1 over 5. 0, 0, 0. So that will be 3 pi over 10. That's the answer. Okay. The volume of the solid obtained by revolving the region bounded by the curve. I have cosine now. We have cosine. That will be cosine x. Y equals 0 from 0 to pi over 2. That's what I care about. Y equals 0 means the x-axis. This is 1. About the line y equal minus 1. This is the line y equal minus 1. Okay. So I have, I'm talking about this strip where it will be, this is the bigger and this is the smaller. So R of y will be what? Cosine x minus 1, another 1 plus cosine x. Small r of x, sorry. R of x. Perpendicular to the axis, I'm dealing with x. Small r of x will be 0 minus 1, and that is 1. So the area will be by 1 plus cosine x square minus 1 square. So the volume, that from where to where? From 0 to pi over 2. Very clear. From 0 to pi over 2. By 1 plus cosine x square minus 1 dx. That's the answer. Okay, it was bounded by the curve. This. Isosceles triangle. Yeah, this is a nice one. Seems to be. Let us see what will happen. I have a isosceles triangle. Okay, of height 4. It's a triangle of height 4. So what is the area of this isosceles triangle? It will be half the base. Triangle has 2 sides of equal length. So the height is 4. I have half 4 times the base. So that give me 2 times the base. Okay. So now let me see what is the base. The base of the solid is the region bounded by the curves y equal x square. And this is square root of x. This is 0 to 1. Okay. That will be my base. So the base will be what? Will be square root of x minus x squared. So this equal to square root of x minus x squared. So the volume will be from 0 to 1, this 2x to the power half minus 2x squared dx. And that will be what? Add 1, 2 times 2 over 3, x to the power 3 over 2, is 2x cubed over 3 from 0 to 1. That will be 4 over 3 minus 2 over 3 minus 0, and that 2 over 3, which is this one. Okay. Included by the curves about the line y equal to. Okay. Let me draw the curve. This is 1 minus x squared. And y equals 0, which is the x-axis. I'm talking about this region. Okay. And about the line y equal to. This is my line y equal to. So now I choose the strip. It's perpendicular to this, so it will be this one. Okay. So I have r of x is 2 minus 0, the long one, and small radius will be what? Will be 2 minus 1 minus x squared. That give me 1 plus x squared. Okay. And from where to where? From minus 1 to 1. So the volume will be integral from minus 1 to 1 by, what is the area? Forget to write the area. It will be by 4 or 2 squared. Let me write it 2 squared. Minus 1 plus x squared all squared. That will be the area. So that will be by 4 minus 1 minus 2x minus x squared dx. That will be by minus 1 to 1. I have what? 3 minus 2. This is 2x squared, sorry. And this is x to the power 4. I need square of this. 3 minus 2x squared minus x to the power 4. This is even, so I can write it 2 by from 0 to 1, 3 minus 2x squared minus x to the power dx. So it will be 3x minus 2x cubed over 3 minus x to the power 5 over 5. Don't forget the by from 0 to 1. That give me by 3 minus 2 over 3 minus 1 over 5. Okay. Don't forget, I make it 0. That's 2. There is 2 here. There is 2 here. I missed the 2. That's really 2 by, because I make it from 0 to 1. Okay. That will be over 15, which is what? 45 minus in 5 minus 10. 15, 10, 3 minus 3. That will be what? 35 minus 32 times 2, 64 by over 15, which is this. The base of the solid, first quadrant, squares. Huh? I have squares. Okay. Let me find the base. I know the area will be the base square. Now let me find the base. The base, he said what? Line y equal x, y equals square root of x. This is my base. So this is the base. So the base will be square root of x minus x. That will be the base. Wait a minute. Perpendicular to the y-axis. Sorry. Yeah, read the question. This is the square root of x, and I want it to be perpendicular to the y-axis. So it'll be like this. I need to write everything in terms of y. So this is x equal y square. This is x equal y. Okay. From where to where y values, this is 1. Okay, and this is 1. So from 0 to 1. No problem with this. So the bigger radius, the outer radius, the outer radius in terms of y, sorry, will be the line. So I have y square. It's no, it's y square. Yes, the small radius. No, wait a minute. The bigger radius is the line, which is x equal y, and out the inner radius will be the square root, which is x equal y square. So that is y square. So I have the area, or the area, which is the base square. So what is the base? Not the inner radius. Sorry, what I'm writing. The base will be what? Y minus y square. Yeah, sorry. I need the square. I don't need that. Okay. The base will be y minus y square. And the area will be this square. I'm dealing with the square. Why I'm going to the other way? Okay. I don't have outer radius or inner radius. Okay. Y minus y square square. So the volume from where to where? From 0 to 1 of this, which is y square minus 2y cubed plus y to the power 4 dy, which is this. Okay, now I have small circles by the curve, and the cross section are perpendicular to the x-axis. Okay, so I have things in terms of x. Let me graph the functions. I graph the function. I have e to the power x, y equals 0, which is the x-axis, and I have the y-axis and x equal 1. So I'm talking about this area. I'm talking about this area, this region. Okay, so the base, let me write the line, draw the line. So the base, what? Ex. Don't forget, this is 2r. So x, so r equal what? Half ax. And the area will be pi over 2 r square. So that give me what? Pi over 8, pi over 2 times e to the power 2x over 4. So it's pi over 8 e to the power 2x. And the volume will be the integral from 0 to 1, from 0 to 1 of this. So pi over 8 e to the power 2x dx. That give me pi over 8 times half e to the power 2x from 0 to 1. That give me pi over 16 times what? E square minus e to the power 0 minus, which is this. Okay. Now he gave me a graph of a region, and he want what? Well, the shaded region about the y-axis. He tell me it's about the y-axis, and he put x equal y, x, oh, everything is here. Okay, so what will be the outer radius about what? About the y-axis. I'm doing it about the y-axis. So the outer radius will be 4 minus y. I want the y in terms of y, since I'm doing it perpendicular to the axis of revolution. This is my axis of revolution. Small r of y will be y. Okay. Is it? No, wait a minute. It is 4 minus y is perpendicular to the y-axis. Perpendicular to the y-axis. So it will be 4 will be this one minus this one. Yeah. From where to where? From 1 to this point, y, which is 2. So the volume should be the integral about this reason, okay? From 1 to 2 of what? What is the area? Will be y 4 minus y square minus y square. That from 1 to 2, 16 minus 8y plus y square minus y square times pi. That will be pi. This is cancelled. Okay. 16x minus 4y minus 4y squared. 16x, 16y. Look at dy from 1 to 2. Let me see what will happen. By 32 minus 16 minus 16 minus 4. That will be by 16 minus 12. That can be 4 by, which is this. Okay. The region bounded by the curve y equal x cubed, the line y equal this, the volume of the line y equal 8. Okay. What will happen here? We have the region. I have y equal x cubed, y equal 4x in the first quadrant. Let's see, make it in the first quadrant. Very clear. I'm working here. I'm talking about this. This is not included. This is not what I'm looking. This is my line. Okay. So about the line y equal 8. This is the line y equal 8. So the outer radius will be what? 8 minus x cubed. It will be 8 minus x cubed. And the inner radius, in terms of x, will be 8 minus 4x. Okay. From where to where? From 0 to 2. Yeah, I know. 2. Yeah, you can equate them or you can see it very clear. This is 8, this is 8. So they intersect at 0 and 2. Okay. So the volume, yeah, so I think there's calculation. Let me write it here. The volume will be the integral from 0 to 2 of what? And the area will be by this square minus this square. Now the calculation. I have pi outside. You have what? 64 minus 16x cubed plus x to the power 6 minus 8 squared 64 minus 64x, so it will be plus 64x minus 16x squared dx. And that is what? By from 0 to 2, I have x to the power 6 minus 16x cubed. This is cancelled. Minus 16x squared plus 64x dx, which is okay, nice. The base of cell obtained by the curve, semicircle. This is semicircle. Okay. So I need to deal with the base. What is the base? I have y equal x square, y equal 0, which is the x-axis, and x equal 1. So I'm talking about this region. So it is my base. And I want it to be to the x-axis. So I have this. So my base will be what? X squared. Don't forget, this is 2r. This is 2r. So r equal x squared over 2. And this is my circle, and the area will be pi over 2 r squared. That will be pi over 2 r to the x to the power 4 over 4. That will be pi over 8 x to the power 4. So the volume, and that from where to where? From 0 to 1, very clear. That the volume will be from 0 to 1, this area, dx. That will be pi over 8 x to the power 5 over 5 from 0 to 1. That is pi over 40. Okay. Pi equal cube root of x. Let me graph the region. This is the region, cube root of x, something like this. And y equals 0 and x equal 8. Y equals 0, which is the x-axis. So I'm talking about this region. Okay, about what? The x-axis. خلاص. I take the line perpendicular to this, so it will be this one. This is my axis of revolution. Okay. So I have r of x. It will be a disk, huh? X to the power 1 over 3. So the volume, this is 0 to 8, will be the integral from 0 to 8 by this square. The area will be by x to the power 1 over 3 square, which is x to the power 2 over 3 dx. That will be by times 3 over 5, 3 over 5, x to the power 5 over 3 from 0 to 8. That will be what? 3 over 5 by times cube root of 8 is 2, 2 to the power 5 times 32 minus 0. So that will be 96 by over 5, which is this one. The volume of the solid. Okay, generated by rotation, by rotating, by rotation the region between this and this about the y-axis. Let me graph the region first. They are easy ones, so you can graph the region. I have y equal 1 over x, y equal x square, x equal half. Wait, x equal half means what? X equal half. This will be 2. X equal half is something here. Something like that. That will be x equal half. The region. Wait a minute. Yeah, I think I need to do it in different colors to see it. This is y equal x square. This is y equal 1 over x. And I want x equal half. X equal half. About the y-axis. Don't forget, it's about the y-axis, not the x-axis. X equal half. How x equal half will cut it? By the way, this point is what? Let me see what is the point of intersection for this to do. It will be, I have x squared equal 1 over x. So I have x cube equal 1, so x equal 1. So that point is 1. Okay. between this and x equal half. When I do x equal half, it means and x squared, it will be 1 over 4. And the y equal 1 will be 2. It will be something like this. Okay. Yeah, but the rotation is about what? About the y-axis. About the y-axis. Yeah, be careful. Yes, yes. I want it about the y-axis. So my strip or my line will have two places. This one, this is one. Yeah. And they know this point. Yeah, be careful here. Calculation need to be careful. This point is at x equal, this point is 1, 1. So y is 1 because I need to deal with y. So it is, and this point is what? It will be half and 1 over 4. And this point will be half and 2. So I have two regions. I need to deal with two regions. Yeah, let me use different color. I know which color I now choose. This is region 1. And this is region 2. So let me call this V1 and call this V2. So V1 from where to where? From 1 to 2. From y equal 1. Yeah, this one is the nice one. Let me go back to the blue one. Yeah, very nice one. It has V1, the upper one, from y equal 1 to y equal 2. And I have what? I have from y equal 1, look at this region, talking about this region, huh? And above, huh? Okay. So it is, the upper is 1 over x in terms of y. I need to change everything in terms of y. Don't forget. So I have x equal 1 over y. Okay. And they have, what is the other one? X equals square root of y. And this one, x equals square root of y, since I'm dealing with the first quadrant. Everything in the first quadrant. And they have r of y, the upper is what? 1 over y. Okay. And the lower will be what? The upper is 1 over y. And the lower is x equal half. So half. The lower is half. So the volume 1 will be by, what is the area here? It will be by 1 over y squared minus 1 over 4. You have two regions. Okay. So this will be by integral from 1 to 2, 1 over y squared minus 1 over 4 dy. This is volume 1, the upper volume. The lower volume, V2, is from where? From y equal 1 over 4 to y equal 1. And what is r of y? Talking about this lower region. Call it V2. V2 will be what? What is the upper side? The upper will be square root of y, and the lower will be 1 over 4, 1 over 2. So the area will be by y minus 1. And the volume V2 will be integral from y minus 1 over d V1 plus V, which is this one. Yeah, exactly. Okay, nice one. You have two regions. Okay, is the triangular region bounded by this y equal x, y equal 1, x equals 0. Okay. What is it? Yeah, this one before. Okay. Generate by rotating the region closed by the curve y equal 2 square root of x, which is this one, and the lines y equal 2, which is at x equal 1. I have y equal 2. This is y equal 2. And x equals 0, which is the y-axis. So I'm talking about this region. This is y. Let's think about what? About the x-axis. Okay. So I have, this is my line. So I have the outer radius will be 2, and the inner radius will be square root of x. 2 square root of x, the function, which is 2 square root of x. Sorry. So the area will be by 4 minus 4x. And the volume from where to where? From 0 to 1. From 0 to 1. By 0 to 1, 4 minus 4x dx. That give me by 4x minus 2x squared from 0 to 1. That give me by 4 minus 2, which is 2 pi. Okay. What is this? The base of a triangular region bounded by this line. Let me change the color. This is what? Y equal x, y equal 1, x equals 0, which is the y-axis. I'm talking about this region. Okay, which is triangular region. Okay. If the cross section are semicircles. Semicircle. Diameters are angle. Okay. So I need to find the base. What will be the base? Will be 2r. Which is this one. And that is equal to what? X. That will be equal to x. So r equal x over 2. Okay, and what is the volume? From where to where? From 0 to 1. Perpendicular to the y-axis. Perpendicular to the y-axis. So it should be like this. Yeah, in terms of y. So 2r equal what? Y. So r equal y over 2. Now from 0 to 1. So the volume will be y over 2, integral from 0 to 1, perpendicular to the y-axis. Okay. I have y square over 4 dy. That gives me y over 8, y cubed over 3 from 0 to 1. That gives me y over 24, which is this one. Yeah, in terms of y, perpendicular to the y-axis. Okay. The region enclosed by this the curve y equal e to the power x minus 1, and the line is this, about the x-axis, the volume is generated equal to what? Okay, let me graph it using this red line. E to the power x minus 1, doing something like this. So this is at x equal 1. It is 1. This is 1. Okay. And the line x equal 1 and x equal 3. This is 3. Assume this is 3. Who cares? And the y equals 0, which is the x-axis. So I'm talking about this region. Okay, we're talking about the x-axis. So I have this line. I have this strip. So I have disk. R of x will be e to the power x minus 1. And the area will be by e to the power x minus 1 square. So the volume will be by from 1 to 3, e to the power 2x minus 2 dx, which is by e minus 2 from 1 to 3 e to x dx. And that will be by over e square times half times e to the power 2x from 1 to 3. That will be by over 2e square of what? E to the power 6 minus e square. That will be by over 2 e to the power 4 minus 1, which is this one. Okay. Squares. Now let us work with the squares. First, let me graph the region. Y equal x cubed. Y equals 0, which is the x-axis, and x equal 1. So I'm talking about this region. Okay. Let me take my line. This will be my line. So the base will be what? X cubed. That will be my base. And they have the square, the area, the base is square. So the area will be x cubed square, which is x to the power 6. So the volume will be what? And that from where to where? From 0 to 1. So I have it from 0 to 1, x to the power 6 dx. Easy one. X to the power 7 over 7. From 0 to 1, that will be 1 over 7. Okay, the volume of the solid, the region bounded by this and this, rotated about the x-axis. Let us see what will happen. Let me graph the region first. I have y equal e to the power x. This is e to the power x. 1 over x plus 1, which is at minus 1. I have asymptotes. So it will be, and they will, at x equals 0, it's 1. So they will intersect here. Okay. And x equals 0, which is the y-axis, and x equal 1. So I'm talking about this region. Okay, and about what? The x-axis. Let us find the outer and the inner range. This is about this one. So r of x will be e to the power x. Small r of x, 1 over x plus 1. And the area, the volume, or the area, will be what? By e to the power 2x minus 1 over x plus 1 all square. Okay, so the volume from where to where? This one is from 0 until 1. So it's from 0 until 1 by e to x minus 1 over x plus 1 square dx. integrate. That will be by half e to x plus 1 over x plus 1 from 0 to 1. That give me by, yeah, be careful here. I have half e square plus half minus what? When I put the 0, minus 1. Minus 1. No, not minus 1. Minus half plus 1. So it will be by half e square plus half minus half. That will be plus 1. I can make it plus or minus 1, sorry. That will be minus 1. Because this is half minus half cancel, minus 1. Okay, yes. Take half outside, half e square minus 2, which is this one. Okay. We try to do this one, then I think I will stop. I think we did many problems. Still, there are many problems wrong. Hold on. I need some time. Okay, total region generated by this y equal x, y equal square root of x, and they want it above the line x equal to, oops, this is x equal to, this is 1. This is my line of rotation. Okay. So my line, this will be my line, perpendicular to the axis of rotation. So everything should be in terms of y. So I have x equal y, and I have x equal y squared. Okay. And what will be capital R of y will be the bigger one, 2 minus y squared. And small r of y, the small one, 2 minus y. So the area will be by 2 minus y square minus 2, no, yeah, minus 2 minus y square. So the volume from where to where is this? From 0 to 1 by the area, by times this, 2 minus y square minus 2 minus y square dy, which is, okay. Yeah, I think I can do more. Okay, what about this one? Y equal n x. This is y equal n x. Y equal 0, x-axis, x equal e. This is x equal e. So I'm talking about this region. About what? Y-axis. Oops. About the y-axis. So this is my line, perpendicular to the axis of revolution. This is my axis of revolution. So I need everything in terms of y. So I have x, e to the power y. So I have the outer radius will be e, and the inner radius will be e to the power y. And the area will be by e squared minus ey all squared. So the volume, and that from where to where? 0, this is e, then e, this is 1. From 0 to 1 in terms of y. By e squared minus e to y dy. That's that. Okay. Okay. The region bounded by the curve. Wow, what a curve. Let me graph it. Y equals square root of x This is y equals square root of x. Y equals square root 2 minus x. So it's 0. And we do something like this. And y equals 0, which is the x-axis. I'm talking about this region, which enclosed by that. About the line, x equals 4. This is x equal. Okay, so I will do the calculation in terms of x equals 4 perpendicular, so it will be this. Oh, I did not change. It will be this. But everything in terms of y. Everything in terms of y. Okay. What that will be, r of y, the outer, it will be this 4 minus this. No, minus 4. Yeah, if you look at it here, it will be this. It will be 4 minus, I think I need everything in terms of y. Okay, so this is means x equal y square. Here I have y square equal 2 minus x, so it means x equal 2 minus y square. So I have 4 minus y square, and the small one, it will be what? 4 minus 2 minus y square, which is 2 plus y square. Okay. Now we'll do the area will be pi times the first square minus the second square. Okay, so the volume from where to where? In terms of y, from 0 to 1. Yeah, very clear. At 1, they agree. So it's from 0 to 1. Pi of this. Yeah, open this parentheses. I have what? 16 minus 8y square plus y to the power 4. Okay. Minus 4. So, yeah, minus 4y square minus y to the power 4 dy. This is cancelled. So I have what? By 0 to 1. 16 minus 4, that is 12 minus 12y square dy. So I can take 12 common factor, 0 to 1, 1 minus y squared dy. And that is my answer. Okay, nice one. How many we have? How many we did? Okay. By this, the cross-sectional are squares. Squares is easy, so let me do this one, and I think I will. Oops. Then I will stop. Yeah, so I have y equals 3x, y equals 3, and x equals 0, which is the y-axis. I'm talking about this region. Okay. So I need the base perpendicular to what? X-axis. So it will be in terms of x. That will make it easier. That will be. So my base will be what? 3 minus 3x. That will be my base. And the area will be 3 minus 3x squared. That will be the volume from 0 to 1, huh? That 3x, yeah, it will be 1. V from 0 to 1 of 3 minus 3x all squared dx. So that will be from 0 to 1, 9 minus 18x plus 9x squared dx. That will make it what? 9x minus 9x squared plus 3x cubed from 0 to 1. Yeah, correct? Yeah. That will be 9 minus 9 plus 3, which is 3, and this is my answer. Okay. Let me stop the recording. I think I did good number of questions. Thank you.